So for the second application that we'll be developing on the Z and Zybo board, we want to introduce the software control CB2CED. What is this? Actually, this is a binary counter of 2 bits with chip enable, and it's also have a chip enable output, so it's cascadable. For doing that, we need 3 pieces of VHDL: the single shot, which is a pulse generator that works in insertion of a signal, and the CB2CED, which is the 2-bit cascadable binary counter with chip enable, and the CB2CE pulse D, which is the top level structure that connects the 2 previous blocks. We're going to design this IP block using the Vivado, and then we're going to generate the hardware configuration necessary for this application, and then we're going to use the SDK to program our board. So I'd like to introduce the single shot, what it is, how it works. This is the GUI for single shot. You see there's a signal switch, there's also clock and reset, and an A shot. So how the single shot works is, if you're waiting for 1, you have pretty much a state machine with 2 states, wait for 1 and wait for 0. If you're waiting for 1, which is the very first state of this state machine, and you assert switch, so if switch is equals to 1, you assert A shot and go to wait for 0. A shot is going to be asserted by the amount of time that your switch is asserted until the next clock event. So you change back to wait for 0 and your A shot goes for 0. So when you trigger this switch again and the SW switch goes for 0, you go back for wait for 1. If you get some state on the switch that it's not what you're waiting for, you pretty much stay on the state. This is what this flow chart is supposed to mean. This is the CB2CED GUI. You have a counter, you have a binary counter with 2 bits output and a chip enable, and you also can cascadable them by connecting the chip enable output of 1 block to the chip enable input of the other block. So chip enable input is connected to A shot from the single shot. This is how this is going to work for our application. You have up-down selection. This is where you have this D here, and you have your output, chip enable output, and also clock and reset to make the counter work. So this is our top level struct. This is how we're going to connect all of them. You have a switch connect to the single shot, then you're going to generate the signal here, internal chip enable, which will connect A shot to chip enable on the CB2CED, and you have the 2 outputs, and the up input goes straight to this block. So it's not really complicated, but something that it has to be done. So for our application to architecture, this is what we'll be using. For Zybo and for Z-board, you can see the connectors between the console and the PS here. You see that we're going to be using the processor subsystem, the exit peripheral, the XeGPIO, and also our user IP that are going to give a name whenever I start to design them. You see that right now I don't have the processor reset here as I have in the very first presentation, but that's something introductory. Then he will be present on this very same design. So as you can see here, you got an overall from the project, and the user will control up the console, the switch will be triggered, the SW will be triggered up and down automatically, and all we have to select actually on the console here will be if the counter is operating in up or down mode, and then the C program does everything for us. So this is the end of this presentation, this introductory presentation, and then we'll have to start to design stuff on Vivado now.